Hello guys, welcome back. I'm Ittehad from the Roots of Unity with the second video of coordinate geometry. Let us start today's video with the relationship of gradients between two lines. When two lines are parallel to each other, the gradient of the lines are equal. This is because the ratio of the change in the values of y to that of x remains unchanged. But when two lines are perpendicular to each other, the relationship looks something like this. For the lines L1 and L2 with gradient M1 and M2, the product of the gradients of both of the lines equals to -1. Let us check out an example. If the gradient of a line is -half, what will be the gradient of the lines that is parallel and perpendicular to the line? The gradient of the line parallel to the line will be -half, since it is the same. The gradient of the line perpendicular can be found using the relationship m1 into m2 is equals to -1. We know the value of gradient of one of the line, which is -half. Putting the values and simplifying the values further in this relationship, we can get the gradient of the perpendicular line. Now, let us see what the equation of a line is. The general equation of a line is in the form y is equals to mx plus c, where m is the gradient of the line and c is a constant. I'll show you how the equation of a line can be found in different cases using examples. Formula used to find the equation of a line is y minus y1 is equals to m into x minus x1, where m is a gradient that can be found using the 2 points x1 y1 and x2 y2. Moving on to our first example. Find the equation of the line passing through the points 1, 2 and 2, 4. At first, we'll find the gradient of the line using the points. The gradient of the line comes 2. Then, we'll take only one point to be used as x1 and y1 in the general form of the equation. We can use either of the point. The final equation will be the same. I'm taking 1, 2. I put the values and simplify the equation, which gives us the equation y is equals to 2x. Now, there can be a case where only one point is given and the gradient is given. This is easier. This spares us from the pain of having to find the gradient. We'll just put the values of the gradient and the point given to find the equation of our line. Let's check out our next case. We are told to find the equation of a line that passes through the point 2, 5 and is parallel to the line y is equals to 3x plus 5. Here, since the lines are parallel to each other, the gradient is the same. Therefore, we can say that the gradient of the line given is 3, so the gradient of our line will also be 3. We know a point, we know the gradient. Now we'll just simply put the values in our general equation and find the equation of the line. What if we are told to find the gradient of the line perpendicular to the given line? Let me use this example. We know that the gradient of the line that is perpendicular to our desired line. Therefore, we can use the relationship between the gradients to find the gradient of our line, which comes 2, and then we'll put the values in the general form again and find our equation. While solving questions from this chapter, you might come across how to find the area of any shape with given coordinates. Let me show you this process with an example. Let's take the triangle ABC. We know the coordinates of the triangle ABC. At first, we'll write the coordinates in this way. We'll write it inside the modulus and multiply it with half. This is kind of like a formula. Notice that I wrote the coordinates of the first point again in the end. Now, I'll multiply the x coordinates of one point with the y coordinates of its adjacent point and add them. After doing so, we'll do the same but in the opposite direction and now subtract them from the initial ones. Since there is a modulus, even if the value found comes negative, it will become positive. We'll just simplify it and find the area of this triangle to be 5 unit square, and in this way we can find the area of any shape given coordinates, but we just need to keep one thing in mind, that the coordinates are in the correct order. That was all for this video. Stay tuned for my last video on coordinate geometry.